So hi, welcome back to my channel, and I'm going to discuss about my summary in chapter 4, which is network access. So network address, we have the physical layer protocols. 4 point, next is the network media, then data link layer protocols, then the media access control. So let's start. Then from our physical layer protocols, we have the what we call type of connections. So we have the different types of connection. For example, we have embedded wireless antennas, also Ethernet switches, internet connection, connect computer to the Ethernet port 1, 2, 3, 4 in a modem. Then we have the network interface cards, or what we call NIC cards, connecting to the wireless LAN with range extender. So network interface cards, and have the physical layer, the types of layers. Then the physical layer media, have the types of we have three types of media. So first we have the copper cable, which indicates as electrical signals. We have the fiber optical cable, indicates as light pulse. Then the wireless as microwave signals. The physical and then the physical layer standards. The TCP/IP standards are implemented in software and governed by the IETF. So I will explain also the physical layer characteristics, and the data is in function from the layer. So it is called Manchester encoding. The data is transferred to 0 and 1. It's a computer language. So also the bandwidth at the physical layer protocol, bandwidth is needed. So I have here sample of conversion with the bandwidth, with the bits, kilobits, also megabits, gigabits, and terabits per second. Gbps, kbps, kbps, mbps, gbps. So the 1 Mbps fundamental unit of a bandwidth, for example, the 1 kbps equals to 1000 bytes per second. Then 1 megabytes per second is equals to 1 million bytes per second. Then 1 gigabyte per second equals to excuse me equals equals to 1 billion. Then the terabits per second, 1 terabits per second is equivalent to 1 trillion bytes per second. Then we have the types of physical media. So excuse me the management ports, we have the fast Ethernet, the gigabit Ethernet, then the USB type A connector. Then for our section 4.2, the network media, then we have the network media for have here the copper media, distinguished as unshielded twisted pair or the UTP cable, shielded twisted pair or the STP cable, also the coaxial cable that is usually used in the television. So I will differentiate the UTP and the STP. Okay, UTP is much cheaper than the STP cable. Then the STP cable is much expensive because it is more secure and more safety because of its cover, and that's all. Then the unshielded twist twisted fair cable is covered with outer jacket. It protects the copper wire from physical damages. Then the twisted pair protects the signal from interference. Excuse me. Then we have the color or the colored plastic insulation. Uh, this electrically insulates wire from each other and identifies each pair. So from the colored plastic insulation, it insulate the flow of the signals in every cable in order to make it organized and avoid hassle and miscommunication. Then the shielded twisted pair cable is consist with jacket, twisted pairs, and in additional it has a foil shields. Foil shields is important in order to give more protection with the twisted pairs. And also the shielded twisted pair cable have its braided or foil shielded, so it acts as more security and more durable than a unshielded twisted pair. So the coaxial cable consists of four elements. We have the outer jacket that protects all the whole cable, then the braided copper shielded. So the importance of the braided shielded here is to avoid the cut or the avoid the uh, scrap the cable. Then the public insulation, it is important to avoid interference, pollution of signals. So at the middle we have the copper conductor. Then the copper conductor, we have the what we call coaxial connectors. We have the BNC N types and the F types. And for the UTP cabling, we have the properties of UTP cabling. UTP cable standards with category, we have the category 3, category 5, and the category 6. They are different with the twist of a pair. So category 3 cable used for voice communication, most often used for phone lines. So as a description, category 3 cable don't have a twisted, it haven't twisted, it is just aligned with each other, the cable, and stick together. And for the category 5 and 5E cable used for data transmission, Cat 5 supports 100 Mbps megabytes per second and can support 1000 megabytes per second, but it's not recommended. Then the category 5 is much better than category 3 because it can handle up to 1000 Mbps, but it is not recommended to use. But lastly, the category 6 cable, the UTP, used for data transmission, an added separator is between each pair, so offers allowing it function at a higher speed. So the category 6 cable is much higher in speed than the other two cables. Then also supports 1000 megabytes per second, 10 gigabits, though 10 gigabits is not recommended. So the maximum of the category 6 is up to 10 gigabits per second, but it is not recommended. It is upon the connection used. Then the UTP connectors, we have the RJ45 UTP plugs and its RJ45 UTP sockets, so its partner. Then a bad connector, it should be wires are exposed, untwisted, and not entirely covered by the from the sheet. So it is not recommended, or it is called bad connectors, because the build of the connector is not necessary. Then if a good connector has a wire has untwisted to the extent necessary attached to the connector. So if you are a Cisco certified, you will easily distinguish the difference of bad and good connector just by seeing it. The types of UTP cable, we have the T568A and the T568B. The difference between these two is the location of pair 2 and pair 3 of cable, the color green and the color orange. They were swapped in the testing UTP cables. Then we have the what we call testing parameters in order to test the UTP cable if it's running, or if it is ready to use, or it is malfunction. So we have the what we call the warm up, cable length, signal loss due to a intuition, also crosstalk. Then we have the properties of optic fiber cabling. We have fiber media cable. Fiber media cable has a jacket. So it's the outer PVC jacket. So the core is actually the light transmission element at the center of the optical fiber. Then the buffer is used to shield the core. Then cladding made from slight different chemicals that those used to create a core. Then we have the strengthening mechanical material. Strengthening material in order to make it more strengthy or durable. Then we have the types of fiber media. We have the what we call glass core, glass cladding, and the polymetric coating. They are different with the microns diameter. Then also we have the testing fiber cables. We have used tester, or what we call the optical domain reflection. A it is called as optical time domain reflectometer, or the OTDR. Then fiber versus copper. Uh, well known that the fiber is more efficient and faster performance than a copper because it is the latest cable used in this generation, the fiber optic. So we have the data link layer, and then we have the media access control. Then its data link protocols govern how to formal the frame for use on different media. Then different protocols may be in use for different media types. Then we have uh, as I said recently, the standards, protocol standards is very important to follow in order to make your work more powerful and more productive. So lastly is we have the frame. The frame have three basic parts. We have the header, data, and the trailer. It's divided different section about delivering data. So that's all for the chapter 4. Hope you understand what I'm saying. Thank you for watching.